In today's video, we're clearly explaining how solar eclipses work. Welcome. Today, we're exploring the captivating phenomenon of solar eclipses, amazing events where the moon temporarily blocks the sun, creating a breathtaking sky show. By the end of this video, you'll understand exactly why and how solar eclipses happen, the different types you can witness, and how to safely enjoy this cosmic display. First, let's start with the basics. A solar eclipse occurs when the moon moves between the Earth and the Sun in what astronomers call a syzygy, a straight-line alignment of three celestial bodies. This alignment causes the moon to cast a shadow over Earth, leading to a solar eclipse visible in certain areas. During a solar eclipse, the sun appears to darken or disappear partially or completely for a short time, but not every new moon causes an eclipse. That's because the moon's orbit around Earth is tilted about 5 degrees relative to Earth's orbit around the sun. So most of the time, the moon passes slightly above or below the sun in our sky. Only when the new moon happens near one of the 2 points where the moon's orbit crosses the Earth's orbital plane, called nodes, does an eclipse occur. This is why eclipses happen roughly 2 to 5 times per year, and why any given location on Earth experiences a solar eclipse only once every few years or decades. Now, there are 3 main types of solar eclipses: total, partial, and annular. A total solar eclipse happens when the moon completely covers the sun's bright disk or photosphere. This creates a momentary period of darkness during the day, known as totality. The sky can appear twilight-like, stars might become visible, and the sun's outer atmosphere, the corona, shines around the moon like a glowing halo. Totality usually lasts just a few minutes, but is a spectacular sight. On the other hand, a partial solar eclipse is when the moon only blocks part of the sun. If you're outside the narrow path of totality, but still near it, you'll see the sun covered partially, sometimes looking like a bite has been taken out of it. Then there's the annular solar eclipse, which occurs when the moon is farther from Earth in its elliptical orbit. Because the moon appears smaller, it doesn't cover the entire sun, leaving a bright ring or ring of fire around the dark silhouette of the moon. This ring is called an annulus. The moon's shadow during an eclipse has 2 parts, the umbra and the penumbra. The umbra is the darkest part where the sun is fully blocked, and if you're inside this shadow, you experience a total or annular eclipse. Surrounding the umbra is the penumbra, where the sun is only partially obscured, leading to a partial eclipse. Eclipse paths trace narrow bands on Earth's surface because the moon's umbra is relatively small, roughly 100 to 160 kilometers wide. People outside this band see only a partial eclipse or none at all. So how fast does the eclipse move? The moon's shadow races across Earth at speeds up to 5,000 kilometers per hour, depending on location and geometry. This rapid movement is why the period of totality is so brief in any one place. Safety is critical when observing solar eclipses. Looking directly at the sun without proper eye protection can cause permanent damage to your eyes, even during an eclipse. Special eclipse glasses or solar filters are essential. Never look at the sun through regular sunglasses, cameras, or telescopes without certified solar filters. Historically, solar eclipses have fascinated humans for millennia, inspiring myths and scientific inquiry. Today, they're important for research too. Eclipses help scientists study the sun's corona, test physics theories like general relativity, and observe solar phenomena. To catch the next solar eclipse, check eclipse predictions and maps online, noting when and where totality or partial phases will be visible. Planning ahead is key, since the path of totality is narrow and changes with each eclipse. In summary, solar eclipses are powerful reminders of the dynamic motions and alignments in our solar system. They result from the moon passing exactly between Earth and the sun, creating stunning shadows and celestial spectacles. Whether total, partial, or annular eclipses offer a chance to connect with the rhythms of space and time. Thank you for joining this journey into the science of solar eclipses. Remember, the next time the sky darkens during the day, you'll know the incredible cosmic ballet behind this natural wonder. A practical takeaway is that how solar eclipses work matters because it affects real decisions people make every day. From a science perspective, results improve when measurements are checked consistently over time. Experts reduce mistakes by validating assumptions with repeatable tests and clear reference points. Another useful point is to compare multiple signals before drawing a final conclusion. In daily life, better context usually means better choices and fewer avoidable errors.